Hello viewers, Electric Circuits question 11. For this circuit, find the total resistance and the current through the battery and each resistor. Therefore, find the power output of the battery and the power consumed by each resistor. So we have a 20 volt battery, and let's have a look at the different possible paths that an electron could take around the circuit. So an electron could go through the 1 ohm resistor, or it could go through the 2 ohm resistor, or the 3 ohm resistor, or the 4 ohm resistor, or the 5 ohm resistor, or the 6 ohm resistor there. Either way, it's going to only pass through one resistor here, through either the 1 ohm, through 2, 3, 4, 5 or 6. 6 different paths, but each path only contains one resistor, and therefore this circuit is purely parallel, and that means the voltage across each resistor is 20 volts, which is going to make this question nice and easy, certainly when you compare it to the last few questions. So we've got the total resistance, which is going to be 1 to the power of -1 plus 2 to the -1 plus 3 to the -1 plus 4 to the -1 plus 5 to the -1 plus 6 to the -1, all of that to the power of -1, and we find that the total resistance of the circuit is 0.408 ohms. So we have the total resistance of the circuit, and let's find the common current. So the common current will be the current through the part of the circuit that all paths have in common, which was from here round to here, which means the part through the battery, which is going to be obtained by Ohm's law, which is V over R. Voltage of the battery is 20, and we're dividing by 0.408, and if we calculate that, we get a common current of 49 amps. Okay, so we've got the common current. Now let's find the current through each resistor, which is going to be obtained by using that same formula, Ohm's law of V upon R for each individual resistor. So for the 1 ohm resistor, that's going to be V over R, which is 20 over resistance is 1, and we get 20 amps there. For the 2 ohm resistor, that's V over R, which is 20 over 2, which is 10 amps. For the 3 ohm resistor, we get V over R is 20 over 3, and that is 6.67 amps. Then we do the 4 ohm resistor, which is going to be again V over R, which is 20 over 4, giving us 5 amps. Then for the 5 ohm resistor, we have V over R is 20 over 5, which is 4 amps. And then for the 6 ohm resistor, we've got 20 over 6, which is going to be 3.33. So we get 20 over 6, which is 3.33 amps. Okay, so we've got the current across each resistor, and those should be equal to 49 amps when you add them up. So these two between them, the 6.67 amps plus the 3.33 amps, make up 10 amps. So we've got 20 plus 10 plus another 10, 40 so far, plus 5, plus 4, and we do have in total 49 amps there. So the total current through each resistor does add up to the current passing through the common part of the circuit, which is the battery. So that is exactly as we expect. Now let's find the power. So for the power across the battery, so the power of the battery is going to be given by I times V, power is current times voltage. For the battery, we found that the current was 49 amps and the voltage is 20, so we get a power output of the battery of 980 watts. And now let's work out the power consumed by each resistor, which should add up to 980 watts there. So the power of the 1 ohm resistor is I times V, so the current across the 1 ohm resistor, that was, when we calculated that before, we got 20 volts, sorry 20 amps multiplied by the voltage is 20 volts, which gave us 400 watts. For the 2 ohm resistor, we found before that the current was 10, so we've got 10 times 20 giving us 200 watts. Bear in mind that the voltages are all going to be 20 here because there are 20 volts across each resistor. Power of the 3 ohm resistor is IV, which is going to be, for the 3 ohm resistor we got 6.67 times again 20, which is 133.3 watts. The power across the 4 ohm resistor is IV. For the 4 ohm resistor, we found that it was 5 amps times 20, giving us 100 watts. For the 5 ohm resistor, it's IV. Current was 4 times 20, and that gives us 80 watts. And for the 6 ohm resistor, we have the power is, I worked out to be 3.33 multiplied by 20 volts, and we get 66.7 watts there. So let's add up the power consumed by each resistor. So we've got 400 plus 200 is 600. These two between them are 200. So we've got so far 800. 400 plus 200 plus these two is 200. So far 800. Plus another 100 is 900. Plus that 80 gives you 980. So as expected, the power consumed by each resistor adds up to the power that's output by the battery. Thanks for watching. Over and out.